Hi friends, welcome back to another session on process management of operating systems. Now we want to see what inter-process communication is all about. It's one of the important topics in process management. The inter-process communication. So the processes, when we say do not share any resources, especially the memory, because we don't want one process to disturb other process. Therefore strictly the operating system will ensure that the boundaries of each process are properly defined and the process will be allowed to work in that boundary only, will not be allowed to move out of that boundary, especially the memory. The modern operating systems use this process isolation. So why do we require process isolation? So there are three reasons for that. One is security. So this will prevent one process from accessing or corrupting another process data. So maybe knowingly, maybe unknowingly, maybe accidentally, or maybe wantedly, one process may try to overwrite the process on other process data, other process information, other process code. Anything can happen, and that's going to corrupt another process, and we don't want that to happen, and hence we will not allow one process to peep into another process. So they strictly are isolated. Another thing why the isolation requirement is there is the stability. Say one process crashes for some reason, then should not affect other processes, because each process has its own boundary, each process are having their own resources, and if that process crashes, then only that gets affected, and all others continue to work without any uh, complaints, without any problem. So there will be stability in the system. So only the affected component gets switched off or whatever happens, but others continue to run. So for that reason we would like to keep the processes in isolation. Of course, memory protection. So each process has its own address space, therefore we don't want one process to leak into another process memory. So that's where isolation is required. It, in simple terms, means that one process cannot directly read or write into another process memory. That's as simple as that. That one process cannot read or write onto other process memory. So what does that mean? Even if two processes run the same program, their variables are separate. That means if two processes are created from same program, that means if the same program is run two times, then there are two different processes. Each process is run independently, and hence there won't be any connection between one another. So they are isolated, and there won't be any common thing between them. So each thing like the memory, the program counter, the stack, the heap, everything is separate for each process, and therefore they don't share anything in common. So pictorially we can say this is one process, blue is one process, green is another process, and if the blue process tries to use some part of the green process, then it will not be allowed. That's how the operating system is created. But that's not all. That is, in general, one process should not interfere with other process, but there are situations where one process needs to communicate with another process. There we need some mechanism so that one process is allowed to communicate with another process, and that is what the inter-process communication is all about. So it is the mechanism by which multiple processes can exchange data or messages with each other. Yeah, this only through inter-process communication mechanism only communication between two processes can be allowed. As it is, they are isolated, and if you want any special thing to be allowed, like so once in a while if you want two processes to exchange data or some messages, then we should get the IPC in between and make sure that IPC takes care of this exchange properly. And because we are forcibly have to make IPC come into picture, then it is definitely IPC don't come in picture accidentally or by mistake or by noise or something. It has to be specifically called. Therefore, when we are specifically calling this component IPC to help us to share data or messages, then it's not happening accidentally. We very well know that we want to communicate with another process, and hence we are taking help of IPC. Therefore, by mistake, by accident, that cannot happen. So this ensures that the privacy is maintained as long as IPC does not come into picture, and only through IPC two processes can share the data, exchange the data, and so on. So the IPC is a component that allows to coordinate, cooperate, and share information even though they are isolated. Yes, they are isolated. Of course, the two processes are isolated, but only through IPC it is possible to share the information in a cooperative way, and IPC will coordinate how to communicate and all that. So it provides a mechanism to exchange the data or the information among the processes. That is possible only through IPC. Now, why IPC? Of course, that is for information sharing. So we do require sharing of the information among the processes. We require it, and when we require that, we need to use IPC. We can't just open this barrier and say that all processes can mingle with each other. Yes, we cannot do that. Therefore, we keep it isolated. Only now and then it may be required to have connection, then create connection for information sharing whenever required. Otherwise, they are isolated. So this will enhance the computation speed, because we can make subtasks to run in parallel, and they can communicate. These subtasks can communicate among each other and exchange the data. Then we can modulate, we can create the modules for every process and get into something like threads or sub processes, so that they can run parallelly and make the things easier for creation and writing, and then making the process faster, and it will be convenient as and when required. So how IPC enables sharing? So the IPC provides safe and controlled ways for processes to share the data, that is text, images, status updates, and all that will allow to communicate between the processes. And then signals or events, like one process is wanting to read the data from the secondary drive, and there is another process which is responsible for reading the secondary drive. So the first process will request the other process to read the data from that. So then the second one will start reading it. When the reading is done, it will return back a message saying that reading is done and this is what I read and all that. So signals and events. So we just signal one process will signal to another process to say that please read this data from the secondary drive, and the secondary drive is read by another process. Once the reading is done, then the second process sends a signal back to the first process saying that the reading is done. So till now the first process can continue its own activity, because reading a secondary drive is quite slower, therefore it may take a longer period. So we don't want to waste our time of CPU, so the first process may continue working with some other activity. Or like sharing the file descriptors, we have pipes, message queues, shared memory, etc. are used for sharing this. So if you want to connect two processes for sharing, we can create pipes, or we can have message queues, or we can have shared memory. So there are quite number of ways to connect two processes for inter-process communication. So more details we see in the coming sessions. So as of now, that's it about the inter-process communication, why and how, what is inter-process communication, why it is required, and how it can be done. uh, Basically two types of inter-process communications are there, which we are going to see in the coming session. So till then, signing off. So if you find this video of any use, please don't forget to like, share, comment, and please do subscribe to this channel. Thank you.